Sketch the following rectangular approximations. Okay, so the first one wants us to use left endpoints, and it says n equals 5. So that means we need 5 rectangles. And it wants us to go between 1 and 3. Okay, so to find the size of each rectangle, delta x, you do the end minus the beginning, 3 minus 1, divided by how many rectangles you have. So 3 minus 1 is 2/5. So each rectangle is going to be 2/5 big. So if we start at 1, then the next one, 2/5, far from that, is going to be 7/5. And the one after that is going to be 9/5. And then 11/5, and then 13/5, and then 3. Those are my sort of division points. Okay, so I'm going to put those in there. 7/5 is like there, 9/5 is there, 11/5, and 13/5. Okay, and so for each of those boxes down here, we're going to use the left-hand side of the box to get the height of the rectangle. So I'm going to use 1, 7/5, 9/5, 11/5, and 13/5. So at 1, I see it goes all the way up to there. At 7/5, it goes all the way up to there. So there's my first rectangle at 1. At 9/5, it goes all the way up to there. There's my second rectangle at 9/5. 11/5, 13/5. So notice I'm getting the height of each rectangle from the left side of the space at the bottom. Okay, the second one says let's use the right endpoint and let's use 8 rectangles. So again, I'm going to compute delta x, and I'm going from 1 to 4. So I'm going to do 4 minus 1 divided by 8, or 3/8. So if I start at 1, the next one's going to be at 11/8. I'm just adding 3/8 over and over again. And then 14/8, 17/8, 20/8, 23/8, 26/8, 29/8, and 32/8, which is the same as 4. Okay, so I have those 8 rectangles. I'm going to put them in there. So 11/8, 14/8, 17/8, 20/8, 23/8, 26/8, 29/8, and 32/8. And I want to use the right-hand side to get the height of each rectangle. So for this first space down here, I'm going to use this 11/8 to get the height of my rectangle. For the second space, I'm going to use that 14/8. For the third, I'm using 17/8. For the fourth, I'm using 20/8. For the fifth, I'm using 23/8. For the sixth, I'm using 26/8. For the seventh, I'm using 29/8. And for the last one, I'm using 32/8. So what you notice is that some of the rectangles seem to be above the curve, like those, and others seem to be below the curve. You see there's some empty space in there, and that's okay. That's why we call it an approximation. But do you see that this approximation is better than the last approximation we did? So the more rectangles you use, the better your approximation is going to get. Okay, the last one wants us to use the midpoint of each rectangle to find the height. Okay, so we're going from 2 to 4, and we're using 6 rectangles. So delta x is going to be 4 minus 2 divided by 6, 2/6, or 1/3. Okay, so I'm starting at 2. 2 plus 1/3 makes 7/3, and then 8/3, and then 9/3, which is the same as 3, and then 10/3, 11/3, and 12/3, which is the same as 4. So I'm starting here at 2, I'm ending at 4, I'm breaking it into thirds, and I'm going to use the midpoint to get the height. So if you notice, the middle of each of these places is what I'm going to use to get the height. So I'm going to go like here to the middle, and here to the middle. Okay, so in here, I'm not going to use the left, I'm not going to use the right, I'm going to use the middle, like that. And then the middle, like that. So I'm going to the middle of each thing and making a box of that height. It's kind of hard to do. I should try to zoom in for you. Okay, so there's my approximations.